Welcome everyone. Let us look at what we call molecules. Okay, we are going to see what molecules are, and then we are going to also look at what we call valency, and then from there we'll also look at what we call radicals, and then we'll look at how to write chemical formulas. Okay, so those are the objectives of this session. We want to know what molecules are, what a valency is, how to write the chemical formula for different molecules and compounds, and then in writing that we'll basically know what valencies are. So we are saying that in chemistry we'll basically look at elements. Have it in your mind that everything that is around us has elements. Okay, everything that is around us is having what? Elements. So these elements can be existing purely. That is to say that you can have an object that is having purely one element, or you can have an element that is combined with the other elements. Okay, so what we are saying here is that for a molecule is the smallest part of an element or a component that can exist on its own. Okay, that can normally exist on its own. And let's use the example of oxygen. Oxygen here is O2, right? This is what we have here. What does this mean? It means that oxygen exists in a way that it has two atoms, okay, two atoms combined, and it exists as a molecule that consists of two atoms, right? So that molecule we are saying is the smallest part of one element that can exist on its own. In this case, the element is basically oxygen. Oxygen is an element. Okay, so the oxygen molecule exists as a diatomic molecule, meaning that it always exists as two molecules. So most of the, two atoms. Most of the gases, even water, they exist as molecules. Okay, so the molecule of water is H2O, meaning that you will have one oxygen atom combining with two hydrogen atoms to form one molecule of water. Okay, and this example here is an illustration of another thing that you can have. You can have a molecule that consists of two different types of atoms, and in this case we have the oxygen atom, and then you also have the hydrogen atom, the two hydrogen atoms. So you can have a molecule that has atoms that are of the same element, but you can also still have a molecule that consists of atoms of different elements, just like water. So oxygen is two atoms, but those two atoms are of oxygen, so it's of the same element. So here we are having calcium carbonate. Calcium carbonate, calcium is an element, carbon is an element, and then we have also oxygen here. So we are having different atoms combined, in this case, to form one molecule of calcium carbonate. Okay, but of course we'll see later on that we are not saying that in calcium carbonate the carbon is existing as on its own. But basically, you see that this here is what we shall call a radical later. So it is existing as the separate group here, and then combining with calcium. That's something that we shall see later on. Okay, so I guess that is very clear. We are saying that we have elements, um, many of them, but these elements can exist as molecules. That is, the molecules are the smallest part of the element that can exist on their own normally. Okay, and we have these molecules being formed as a result of combination of atoms, and these atoms can be of the same element or can be of different elements. So what we call the atomic molecules, these molecules that consist they have two atoms, okay? And most of the gases, chlorine, hydrogen, oxygen, and nitrogen, these are diatomic gases. So we can say they exist as diatomic molecules, okay? So we have, for example, hydrogen element, hydrogen here. This the symbol for hydrogen. So it does not exist like that. It exists as H2. That is to say, you have two hydrogen atoms combined to form hydrogen gas. Okay. The same thing with oxygen. You have two octane molecule atoms combined to form octane molecule. So it exists as a diatomic molecule. Okay. We also have triatomic, meaning three, tri, tetra, four, poly, meaning many. Okay, so tri ozone, the ozone, which is basically you have three atoms, just like that. That is ozone here, triatomic, and then we have tetraatomic, four. This you have four atoms existing as a molecule. So phosphorus is one of those that you will have four atoms of phosphorus existing together. And then poly, meaning, and in this case, the example we have here is sulfur. Okay, sulfur. That is 8 atoms of sulfur combined together to existence at a polyatomic molecule. Let's look at what we call valence. Valence refers to the power of an element of a radical to combine with others, okay, with the other elements, that's with other radicals. So look at it this way, that when you have sodium, that's the symbol for sodium, combining with, let us say, sodium ions combining with chloride ions, we expect to form sodium chloride, right? How many chlorides will combine with sodium? Yet under what ratio, for example? Under what ratio? Are you going to have sodium like this? Are you going to have it? No, it's not like that, and this is wrong. Sodium chloride is written like that. So why are we having let us say ratio of 1 to 1? Why are we having such a thing? Okay, this is basically related to valency. Okay, if the power was, for example, 2, then you could expect changes here. Here you would expect to see some either it is a 2 here or a 2 here. Okay, but that is not the case. So we are saying a valency is the power of one element or a radical to combine with others. Okay, so we can also say it's the number of hydrogen atoms that an element can combine with or even displace from an acid. Okay, so that is what we call a valence. So let's go deeper into understanding what valences are. So each element has a valence. Okay, we have elements that have more than one valence. And for example, in our case here, we have iron. It has a valence of 2. It also has a valence of 3. We will see that iron actually belongs to a special group of metals that we call the transition metals. For them, they have more than one valence. Okay, for them they have that ability. Okay, so but generally the rest of the elements that we are having here are having at least one valence. Do you need to memorize them? Not necessarily. The things will be very familiar with you as you go on with the studying chemistry. Okay, potassium has a valence of 1, sodium 1, lithium 1, silver 1, calcium 2, magnesium 2, copper 2, iron we said it has a valence of 2 and 3, lead has 2, zinc 2, barium 2, mercury 2, aluminium 3, and then we got the nanometals. Hydrogen has a valence of 1, chlorine 1, oxygen 2, sulfur 2, nitrogen 3, carbon 4. Okay, so what does it mean? Potassium has a valence of 1. It means it can only combine with one hydrogen atom. Okay, or it can displace one hydrogen atom from an acid. That is what it means. Sodium has a valence of 1. That means it can combine with one hydrogen atom or displace one hydrogen atom from one acid. Lead has a valence of 2. That means that it can combine with 2 hydrogen atoms or displace 2 hydrogen atoms from an acid. This is basically what this all means. Okay, it's basically like we are using hydrogen as a reference point. That's basically what it means for the other elements. Okay, and then we go to another concept called radicals. What is the radical? We have groups of atoms or even a single atom that has unpaired electrons. Okay, and therefore this makes them very, very reactive. So we're saying a radical is a group of atoms or a single atom that has unpaired electrons. Okay, they are different from what you call ions. Ions here these are basically atoms that have a net charge. They can be positively charged and we call them cations, or they can be having a negative charge and we call them anions. Okay, please note that radicals, these are groups of atoms or atoms, okay, that have unpaired electrons. Okay, remember, when you have unpaired electrons, usually the element is unstable. It basically looks for other electrons to pair with that becomes stable. Okay, and that's why radicals are very reactive. Okay, they are highly reactive because of that. So the radicals that we have here, there are quite many. We have hydroxide radical with a valence of 1, chloride with a valence of negative 1, even hydroxide -1, nitrate -1, nitrite -1. Then you have ammonia positive, that is 1, hydrogen carbonate -1, chlorate -1, permanganate -1, hydrogen sulfate -1, hydrogen sulfide -1, oxide -2, carbonate -2, sulfate -2, sulfide -2, sulfide -2, phosphate -3, and then nitrite -3. Okay, you don't need to memorize this. You basically have them into your head as time goes on. The more practice you make about writing this, the formula for this, the more it will stick into your head, and you will basically always remember. Okay, so we go to what you call chemical formula. Chemical formulae. So what are these? A chemical formula is a way of representing a composition of a chemical compound by the symbols of the elements that are present and indicating the number or the proportion of each of these elements. So let's use the example of water. Water, the chemical formula for water is H2O. Okay? H2O, just like what you see here. What does this tell you? It tells you that we have water is existing as a molecule, right? That's something that we looked at earlier on. So in that molecule of water, you have 2 hydrogen atoms combining with 1 hydrogen atom. Okay? So it is telling you that for every oxygen molecule, you need to have 2 hydrogen atoms. Are we together? For you to form 1 molecule of water, you need to have, for every oxygen atom that you have, you need to have 2 hydrogen atoms. So this is basically telling you that you have 2 to 1. This is the relative proportion, okay, of each of the elements in that compound. Remember, a compound is formed when you have elements combining chemically through a fixed ratio to form a compound. Okay, so that ratio is basically what is here. And when you use a chemical symbol and the subscripts, these figures that we put down, if there was one here, these are the ones we call the subscripts. Okay, these are the ones we call the subscripts. The subscripts indicate the proportion of each element within that compound. Okay, so how do we write the chemical formulas for the different elements? The steps are simple. The first thing is you need to know the symbol of the elements that are in that compound, or at least the formula of the radicals that you find in that compound. And then you write the valence of each of these species in the compound on the top right hand side, the top right hand corner. So let us illustrate this using water, right? So we are saying that you write the valency. You write the valency top right hand corner. This is where this is the area we are referring to. This is the area we are referring to. And then the third step is you reverse the valencies and write them at the bottom. You write them here. Usually we don't write 1. If the valence is 1 here, we don't write it. This is what it means. Okay. So those are the rules. So we are going to apply those rules in writing some chemical formulas. Sodium chloride. Sodium chloride is written as Na. That is the symbol for the element that we have. That is sodium. And then the symbol for chloride. So that is the formula for chloride. Like that. Then we write the valency of each, the valence of sodium, and then the valence of chloride. So let's go back and check the valency of sodium and the valence of chloride. So we go to our, here we have chloride, -1, you can see it here. So we are remaining with sodium. Sodium is here, 1. So we take them there. So we have -1, and then we have 1 here. So if we are to follow those rules, 1 comes, -1 comes here, then 1 comes here. But remember the rule, never write a 1 in the chemical formula. So therefore we have sodium chloride like that. That's the chemical formula for sodium chloride. Okay? We go to calcium chloride. So this symbol for calcium is Ca. And then chloride, we already know it. We already also know the valence of chloride, -1. So we'll check calcium. Calcium is what? Calcium, we are moving downwards. Calcium is a metal, right? So calcium is here, valency of 2. So we move down, valence of 2. Interchange. You have this was -1, -1, and then you bring 2 down here, and here supposed to be around there. So this calcium chloride will be, remember we don't write 1, right? So Ca. That is calcium chloride. So we go to calcium carbonate. We already know calcium, and then the carbonate. The carbonate is like that. That's the formula for the carbonate. So we check the valency for the carbonate. So we go to the valency for the carbonate, -2. Okay, -2. So move down. Interchange. Okay, so when we interchange, we get a 2. 2 here, and then a negative 2 here. These ones basically cancel out. Okay, they cancel out. What does this mean? For each of these, the point is that the charges should actually balance. So this is to say, for the bar, the charges, this one is negative, and then this one positive. For these to balance, you need for every two calcium cations, they have to combine with the two carbonate anions. Okay, so these ones actually balance out. So you have calcium carbonate like that. This cancels with that. But they are the same, right? The same thing with magnesium. So you have magnesium, and then you have the oxide. Negative 2, this one 2. They basically cancel out. You have a 2 and 2, they cancel out here. So you have magnesium oxide. I hope that is clear. Now let's look at what we call the types of chemical formulas. We have empirical formulas. Empirical formulas, these are basically the simplest whole number ratio of the elements within a compound. Remember, we said that we form a compound when elements combine chemically in a fixed ratio. So what is that ratio? The empirical formula tells us the ratio of that combination. So for example, glucose. The glucose molecule has 6 carbon atoms, 12 hydrogen atoms, 6 oxygen atoms. What ratio is that? The simplest ratio is to divide this one by 6, this one by 6, this one by 6, so that you have 1, 2, and then 1. So this is the ratio. 1, 2, this is 1 to 2 to 1. This is what is basically here, 1 to 2 to 1. So this is the simplest whole number ratio for glucose. Okay? And this is very important. We shall have some calculations in our subsequent lesson on how we can determine the empirical formula of the compound if we know the ratios. Okay? So we can determine how much substance was used in a reaction if we know how much was produced and if we know the empirical formula of what was produced. We shall look at that. And then they will have what you call the molecular formula. It tells us the actual number of atoms in each element in the molecule. Okay, so here you don't basically change anything. The way it is here is the way, for example, water is H2O, and that's it. This is to say, in a molecule of water, you have 2 hydrogen atoms and 1 oxygen atom. And then the structural formula tells us the arrangement of the atoms in a particular molecule. So here, this is basically showing us how the glucose molecule looks like. Remember, it is this one, it's the same one here. It's the same, nothing has changed, but basically how the position of the atoms and how they are bonded to one another. Here you don't know whether how the oxygen is bonded to hydrogen. You don't know. But here it tells us how they are bonded and gives us the structure of the molecule. So here we have 6 carbon atoms. At each corner here, you have a carbon, 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 carbon. Those are 5 plus this carbon here. Those are 6 carbon atoms. And then we move to oxygen. We are saying that oxygen are 6. 1, 2, 3, 4, 5, 6. Okay. And then we are saying that the hydrogen are 12. Are they 12? Okay. Let's see. You have 3 here. You have 4. Of course, you have others that you can't really see. You have another here. You have another here. You have another here. Okay. So the structure formula gives us how the different atoms are bonded to one another in a particular molecule. So that marks the end of this presentation, where we have looked at molecules. Okay, we're saying that we have elements that can exist as molecules, and most of these are, for example, the gases and even water. Okay, with the existence as molecule can be that you have 2 atoms existing on their own as a molecule. And we have probably hydrogen, oxygen, and nitrogen behaving like this. Okay, and then we can classify these different molecules depending on how many atoms there are in that molecule. Okay, and we talked about diatomic molecules, we talked about triatomic molecules, tetraatomic molecules, and then polyatomic molecules. Okay, and then we talked about valency. We are saying elements can combine with hydrogen, but the number of hydrogen atoms that a given element or radical can combine with is what we call the valency. Okay, it can also, the valency can also be the number of hydrogen atoms that an element or radical can displace in an acid. Okay, and then we looked at how to write chemical formula. In a molecule or in a compound, we have what we call symbols representing, which are basically letters, or a letter that can represent an element. Okay, in a compound, we are saying that a compound is when we have atoms or different elements combining chemically. That's when you get a compound, right? Now, that combination follows the fixed ratio. Okay, but for each molecule of a compound, we can always represent the number of atoms in that compound for each of the elements using subscripts. Okay, so we looked at how to write the chemical formula for magnesium oxide, calcium carbonate, calcium chloride, and then sodium chloride. Okay, we saw the different rules that you can, or the different steps that you can follow in writing this chemical formula. You need to practice more in the assignment below.